Guys, welcome to this class. For this class, we'll be discussing gravitational acceleration on an inclined plane. So, okay, so this is Noble Mind Science Course Online. If you have not subscribed, please click on the subscribe button, click on the notifications so that when we upload a new video, YouTube will notify you. I remain to Mike. Please, you can reach us through the WhatsApp number that is showing right on your screen. So please get your writing materials so that we can go straight to the class for today. Motion down an inclined plane. That's what we're looking at. See, so if the friction between an object and the inclined plane in which it is in contact is neglected, the object will tend to slip down the inclined surface faster because of the component of the acceleration due to gravity. Okay, so we have discussed inclined plane in some of when we discuss friction, we discuss inclined plane. So for this particular gravitational motion, the acceleration due to gravity can be resolved into two components. That is, the components along the plane and the component perpendicular to the plane. Is that okay? So this is the picture of what I'm talking about. At this point B, the initial velocity is equal to 0 for this box. Now, if the friction between this box and this inclined plane is neglected, then this block will slip down, right? It will slip down. Now it is slipping down. The acceleration due to gravity acting on it is the one that is along this plane, while the one that is perpendicular to the plane is the one that is acting opposite to the normal reaction to this particular um, box. Okay, so this acceleration due to gravity can actually be resolved into two components, and when you resolve them into two components, the component that is parallel to the plane, gs equals to g sine theta, while the one that is perpendicular to the plane is g cos theta. That's okay. So if you know your simple trigonometrical ratios, you can actually solve it and get this. But okay, so this is the component that is parallel to the plane, and then this is the component of the acceleration due to gravity that is perpendicular to the plane. Note that the component that is actually moving this box down is the one that is parallel to the plane. So in most of the calculations, it is this one that you are going to use to solve. Is that okay? So if you have a plane that has these definitions, s is equal to the length of the plane, h is the vertical height of the plane, and then the time to slip from this point B to A is t, then the velocity attained at the base of the plane, which is v, then the angle theta, angle of inclination on the plane. You can actually derive some equations, right? There are some equations on motion that you can derive, and those are what we are going to go to straight away. So I've talked about this. Component along the plane is g sine theta, and component perpendicular to the plane is g cos theta. That's okay. So I've said that the component that is moving the body down is the one that is along the plane. So we'll go straight to the equation that are applicable to this scenario. Okay, so assuming we are looking at that plane, I said that at the point of rest, when the body starts rest on top of the plane, initial velocity is equals to 0. So if that is 0 from the first equation of motion for acceleration due to gravity, as far as the object is moving down, g is positive because it is moving in direction of g, right? So we said that g along the plane is g sine theta. So from this equation, u is equals to 0, you have v is equals to gst, which is the component along the plane, and we have said that gs equals to this. The component along the plane is g sine theta. So if you substitute that into this equation, you are going to have that v is equals to gt sine theta. Please take note of these equations, right? This equation is what you have here. Okay, then to find the distance along the plane, you already know that u, initial velocity, equals to 0. Then from this equation, ut plus half gt squared. G along the plane is gs. Okay, so this, since u is equals to 0, this should be 0. So if that is 0, substituting into this equation, you have that s is equals to half gt squared. This will now give us half g sine theta t squared. Okay, so this equation is to find the distance along the plane. This is the equation, and this is how it is derived. Then you can also use the third equation of motion. If you use the third equation of motion, we've said that u is equals to 0. So this will give you v squared is equals to u squared plus 2gx s. So if you, this will be equals to 0, since we said initial velocity is equals to 0. So this gives you v squared is equals to 2g sine theta. Substitute that equation s. Then make s a subject. You have s, if s is a subject, you have v squared is equals to 2g sine theta. Okay, so this is how to derive all these equations. So distance is equals to, depending on the variable that are given to you, you can either use this equation to find the distance or use this one to find the distance along the plane. Alright, now for you to find the vertical height of fall, you can use this. This is what you use. This is where the ball is. This is the vertical height of fall. Then for your trigonometry, you know that sine theta is equals to opposite over hypotenuse, which is h over s. So if you make h the subject, it will be s times sine theta. Now from previously we've gotten that s is equals to v squared over 2g sine theta. So if you substitute this into this equation, we will see that you will now have that v squared all over 2g, v squared all over 2g sine theta, 2g sine theta multiplied by sine theta, So this will cancel out. So what you have finally will now be this. So this is the formula for finding the vertical height of fall of an object that is sliding down an inclined plane. Okay, so take note of all these equations because we're going to apply them to solve some problems. Alright, so this is a sample question that we're asked to solve. A body slides down a plane inclined at 30 degrees to the horizontal, neglecting friction. Calculate the velocity of the body after sliding 10 meters from rest. The time taken to slide the 10-meter distance. Okay, so in this particular equation, you are asked to find the velocity after sliding 10 meters from rest, and you are given the angle of inclination to be 30 degrees. Okay, so So you are giving that distance is, you are giving distance to be 10 meters. You are giving theta to be 30 degrees. T, you don't know T. Then you are asked to find V2, V velocity. So if you look at this variable that you are given, the equation that will relate distance and the angle to find final velocity is the third equation. And from what we got just now, third equation, V is equals to 2g sine theta times s. So if you substitute into those equations, you have 2 times 10 times sine 30 degrees times the distance, which is 10. So if you multiply all that out, this will be 220 times sine theta is 0.5 times 10. So if you work that, V will be equals to the square root of all that, and all that is equals to 100. So your V now will be equals to 10 meters per second. So you see how to apply this equation. Your V is 10 meters per second. Then the time to slide this distance from the second equation, we have that S is equals to, since initial velocity is equals to 0, we have that S equals to half g sine theta times t squared. Okay, so this is, distance is 10, half times 10, sine theta is 0.5 times t squared. Okay, so that will give you 10 is equals to 5. 2 divided 10 is 5. Okay, 5 times 0.5 times t squared. So you can make t squared your subject of formula. T squared will be equals to 10 divided by 2.5. 5 times 0.5 is 2.5. And t will be equals to the square root of that. That is square root of 4. So t will be equals to 2 seconds. Okay. So t is equal to 2 seconds to cover this distance of 10 meters. So that is how to apply this equation to solve some problems, right? This is another question. A smooth body slides down a plane inclined at 60 degrees to the horizontal. Calculate the components of the acceleration of the body along the plane and perpendicular to the plane. 2. The velocity of the body at the base of the plane after 10 seconds. 3. The vertical height of the fall. Okay, so we'll just apply those equations that we got before. Here you are giving theta to be 60 degrees. Okay, so the horizontal component of the velocity is equals to, of the acceleration, is equals to g sine theta. That is the horizontal component, gx. So just substitute into the equation, you have 10 times sine theta is 0.866, and that gives you 8.67 meters per second squares. This is the component along the plane. then perpendicular to the plane is equals to g cos theta, which is equals to 10 times cos theta. Cos theta is 0.5, so that gives us 5 meters per second squared. Okay, so that is that for the first part of the equation. Then the velocity of the body at the base of the plane after 10 seconds. We know that the initial velocity is equals to 0 from rest. So v is equals to u plus gst. This will be equals to 0. So the velocity will now be equals to gst, that is g sine theta times time, is equals to 10 times sine 10 times sine theta. Sine theta is times 60 degree, 0.86 times 10. Okay, so when you work this out, you have 86.7 meters per seconds. So this will be the velocity at the base after 10 seconds. Okay, so vertical height of 4, we said a vertical height of 4 h is equals to v squared all over 2g. So if you substitute into that, it will then be 86.7 squared all over 2 times 10. So if we work that out, you are going to have 375.8 meters. This is what you are going to have. So guys, this is how to use that those equations that we just derived to solve problems. Is that okay? So this is your test page. Please solve these problems. Post your answer on the WhatsApp number that is showing on your screen. I will respond to all your responses and your question and your answers. All right. So this is where we are ending our class for today. Please, if you have not subscribed to this channel, please, what are you waiting for? Subscribe to this channel. We are still working on this channel and we hope to give you the best lectures in physics. Okay, so this is physics class out of your normal brick and work class, and we are bringing it direct to your very doorstep. So please give us a like, give us a thumbs up, put your comment in the comment section, invite your friends, reach us through the number that is showing right on your screen. Is that okay? So please continue to solve more problems so that you get used to how to answer questions in physics, and also review our videos. Right? Invite your friends to come and enjoy this lecture. Thank you. So we'll see you in our next class. Thanks.